Hi, I'm Paketa12 and this is another tutorial especially for you guys. Thank you so much for supporting me. In return, I want to share with you my latest research on Mandelbrot set, and in this tutorial we'll not go for high number of iterations. Instead, we'll do only couple and see what's on the table, see if we can get something nice out of there. But first, let's have a look on some drawings I've done. Okay, so we have this equation formula, and a number it's equal with the previous version squared plus a number, and we know that we start from 0, and this C number, it's a complex number formed by a real part, the red one, and the imaginary part, the green one. And this I has this weird property in which if you square this number I, you get -1. So let's see how we iterate a couple of times. Okay, so z1 it's equal z0 squared plus c. This one it's 0, so we get c in first iteration. In the second one we have z1 squared plus c, so it's c squared plus c, and it's looking very simple. And my questions was how do I square a complex number? So let's have a look on this graph here, where if you use this horizontal line for the real part of the number and the vertical line, the green one, for the imaginary part of the number, you can represent the complex number with these two vectors. If you add them together, it would be like you move the green vector here, right? And then you get a vector c, which is our complex number. So it is a vec2, and it can be represented with a texture, right? So and let's see a little bit about the math. If we square a plus bi, then the rules are the same, so we get a square plus 2abi minus b square, since we have here b square multiply with I square, which is -1. Okay, so and now if I split in colors, right, the red one, the red part, it's the real number, and the green one is the imaginary number, right? So that means the result, all the computation can be done in textures. So yeah, let's do this, okay? And we start clean, okay? And what we need first is the constant chop to set the resolution, okay? So yeah, let's grab a constant chop, okay? And let's say resolution, and 1024 will be good for now. And first we need an UV, okay, because this is how we build the texture for the complex number. Okay, so with a ramp, okay, and this one has to be 32 mono. Okay, and the resolution, it's here. Okay, and now we need a reorder and a flip. Okay. Okay, and this one is bottom left. The reorder has to be 32 RG, so okay, and the second input, it's green. Okay, let's chain a null here. So now we have our UV, okay, and this is our C number. This we need to add each time, okay? And now let's say we start with 0, so we need a constant, and since we'll do math with this texture, with this resolution, the constant will have the same resolution. So constant, okay, everything is 0, so okay, and this one, it's RG also, so 32 RG. Okay, we chain a null here, and in between I insert another null, and I'll make a base. Okay, and I call this base Mandelbrot. Okay, I'll make it a little bit bigger. Okay, I will put here, oh, but it's okay. So like, let's go inside. Okay, and if we look here, we need to square each imaginary and real part of the numbers, and then add, subtract, and then add them, multiply by 2, and we do this here by using a reorder. Okay, and I wanna make something that it will be much easier to see what we're doing, you know, and that is if instead of plugging 0, if I plug this UV, which will be C, in the first iteration. Okay, so now I can see much better what's going on. So this has to be 32 mono. Okay, and yeah, I color this one with the red. Also I need to take the green out. Okay, and I color this green. Okay, now I need to square those, so I use math. Okay, and here square. Okay, the same for here, and I need to subtract them, so subtract. Okay, now we need to multiply them together, so multiply. Okay, and then multiply with 2, so we use a math. Okay, and here we multiply by 2. Okay, and this would be the input into a reorder as the first input, and this the second input, and then we say this, and this texture has to be 32 RG, okay? And now we only need to add the C again. So we use add here, okay? And let's split this in two, okay? And yeah, I will take this here in a select, okay? Okay. And we're done. This is this space now does everything we need. So we can plug the constant 0 back. Let's close this, okay? And now instead of doing a loop, if I only need 2 or 3 iteration, I can just use this base over and over again. So I copy and paste it, and then I use the output from this one into the next input. So I can put them like this, okay? And then I have the last result here. So let's do 2 more, okay? And let's chain them together, okay? And look, we have something quite strange, okay? So what we can do now with this texture is how can we form a surface with what we have here, okay? So this is actually the Z in at one point in after we done 3 iteration. This is our Z, okay? And let's use a matte here, okay? And go for square, add a root, okay? And this has to be 32 mono. And yeah, it's not too fancy, right? And I'm thinking if I copy paste this, and what if I play a little bit with this order here? Instead of going square add root, what if I go root, subtract, and square? And now we get something like cactus. And since the value here are in between 0, 1, I suppose, or they will be in a moment with a level, okay? And what if I want to see the normal map of this? So let's invert, okay, like this. And now if I use a normal, okay, this has to be 32 RGB, and instead we can make this one like this, okay? And let's put a null here, okay? Now we have a normal map, and I want to bump it a little bit, so I use a level here, okay? And take off the clamp input, and now increase the contrast Okay, so you can go high till you get some strange colors like I don't know, here in a couple of steps. Okay, so something like 10 maybe, it's good. And after the normal we can bump it a little more using again a level. Okay, and here in this one also without clamp input, and mask the B channel. Okay, and now if we increase the contrast again, we get some nice colors. And what we can do with this is what if we use a noise for colors, and instead of noise on some pixel positions, let's say, I want to get a noise form according with some directions. So I will use this texture with my normal to get the color. So let's use a noise. Okay, here the same resolution as this one. Okay, oh, something, sorry. Okay, and this goes here. Okay, and this color should be 32 RGB, and color, and let's see now, we don't need this null. Okay, we chain a null here. This is the final, so let's say okay, and let's play here a little bit, because now we need to scale the noise. Okay, okay, and here, okay, and now if we increase the period, we have very nice colors according with the surface we have here. And you can increase this even more, and yeah, the color will change, the ramp for the colors. Okay, and if I want to use a black background, and I can select this, and I multiply this one. Okay, and maybe if you want to get back some lights a little bit, you can use function and go for the exponent. Okay, and this one has to be 32 mono, no, mono. Okay, and yeah, you can have it as you want. And here on seeds you can find I believe infinite palettes of colors. So yeah, and you might wonder what this has to do with Mandelbrot, and since it's not the shape that we know. Okay, and this is because our C here, it only takes values from 0 to 1, so we can use mat here, and let's say here on the X we change 0, 1 from let's say -2 to 1, and on y we go -1.5, 1.5, and yeah, this is the Mandelbrot set. And if we increase the number of iterations now, let's say 3 more, and let's chain them. Okay, we get so many tips, and the iterations will as iteration will go higher and higher, you will quickly lose the any details here, if you, because the most common use way of coloring the fractal, it's required another step that obviously many iterations, and that is something that we'll cover in a future tutorial. And let's see here how we can make this move a little. So let's go back with a couple of iterations. Okay, like this, and here I want to use this place, and I found that this is a very nice way of zooming into fractal. Let me check what's happened here. So okay, first I have to go very low with this. Okay, and okay, and now UV displace, and I can zoom, and if I change the offset, I can change the point where I'm in. Obviously, if I go negative, I have these artifacts of caused by the displace. Okay, so yeah. But let's go, I don't know, let's go on some something a little bit big. Okay, like this. Okay, and here, if you want to add some noise on this surface right here, then you have to make something like this. You grab this UV, you have it here. Okay, and you form a texture with this UV, and this black and white texture as Z. So we use reorder, okay, like this, and here I'll take second input for the blue, and this has to be 32 RGB. Okay, and now I use a noise here. Okay, and I connect this texture, and now let's make this a little bit better. First we need 32 RGB, and let's go a little bit smaller, and yeah, this is how you add some extra noise over this surface. Yeah, so this was my tutorial. You will find also the file attached, and thank you so much for supporting me. I hope you like it. Please comment below, and if you have any idea on maybe future tutorials, let me know. And as I said, thanks to all my patrons, and especially to Breckwood, Roy Gerritsen, Gavin Grinden, and Dimitri Diak. And yeah, I thank you massively, guys, and see you in the next one. Bye.